Our next presenter is Lauren Bansbach, who will be speaking on ponderosa pine seedling physiology after severe wildfire. Does it take a forest to make a forest?
Hi everyone. My research is about ponderosa pines and fire. Many of you have probably heard about all the wildfires across western North America. For ponderosa pine forests here in the Southwest, small, low-severity wildfires leave most of the trees alive and are a natural part of this forest ecosystem. In contrast, big, catastrophic, high-severity wildfires kill most of the trees and result in huge areas of the landscape that are no longer forested even decades after the fire. And even efforts to replant trees in these severely burned areas are often unsuccessful because most of the seedlings don't survive. And so why aren't our forests coming back after severe fire? Well, one obvious difference is that in severely burned areas, there are no more trees. And so it leads me to the question, does it take a forest to make a forest? In other words, does the presence of large mature trees overhead have some sort of beneficial impact on the small developing seedlings down below? To test this, I'm studying ponderosa pine seedlings growing in these two contrasting habitats, a low severity burned area with trees present and a high severity burned area with trees absent. And so one reason I expect a difference between these two habitats is because if you've ever gone walking in the woods, you probably noticed that the presence of big trees overhead actually changes the amount of light, heat, and moisture that you're experiencing. And that's called microclimate. And without trees, the local microclimate is hotter, brighter, and drier. And small seedlings are especially sensitive to changes in microclimate. They can experience great physiological stress under dry conditions, and that's made even worse when in combination with high heat and excess light. And so to relate to these seedlings, just imagine being dehydrated, standing out in the hot, blazing sun all summer long. And so to quantify differences in these seedlings, I'm measuring several plant physiology metrics that relate to light, heat, and water stress in these seedlings. And interestingly, my preliminary results show that the seedlings growing in the severely burned area are significantly more stressed than seedlings growing in the low severity area. So this suggests that maybe it does take a forest to make a forest. Ultimately, the results of my research will help us understand why our forests aren't coming back after severe fire, and they'll help land managers seeking to successfully replant trees after severe fire, and it'll help restore our ponderosa pine forests. Thank you.
So Lauren, tell us where you're from.
So I'm from Missouri.
And what brought you to New Mexico?
I came here for the biology graduate program.
And anything in particular attracted you to the biology, a particular advisor or?
Yeah, so my advisor is great, and I also wanted to study plants here in the beautiful desert Southwest.
You can give a shout out to that advisor.
Oh yeah, David Hansen, and Matthew Hurteau, also Marcy Litvack.
And is Albuquerque what you expected?
Yes, it is much better than what I expected. I didn't really know what to expect. So.
Do you have a favorite forest here?
Oh, well, they're all great.
Okay.
But
Thank you.